So our next presenter is Ed Nabrotzky, and Ed is the Chief Solutions Officer for Omni-ID, and he's going to talk about how IoT equals traceability at the edge. Ed, you should have control. Yeah.
I do. Thanks, Mark. I hope everyone can hear me. And I know that Chief Solutions Officer title is a little bit different, but it means I get to dream and work on the product roadmaps and really develop some of the most interesting applications with our customers as we try and solve their problems and come up with solutions to real common market problems. So I'm pleased to present to you today and talk about some of those and talk a little bit about the ways we solve those problems. Just by way of quick introduction, if you don't know Omni-ID, you should. We're the market leader in industrial RFID and are everywhere in the world in a lot of applications in many different verticals. We really have two main businesses. One is our enterprise asset management business, which is all of our tagging. We sell millions of tags every month in different applications, many very harsh environments. But the second business, which has been our fastest growing business, has been our ProView Solutions business. This one is very specifically targeted at manufacturing. We've developed expertise, software systems capability to really solve some of the very specific material flow problems on the manufacturing plant floor. And this, again, is a growing practice for us that is a focus for our company that we continue to develop. I'll be speaking about both of those businesses today in the context of RFID and manufacturing and how they impact your material flow operation. So first, kind of to set the stage, while you're reading this, as we're talking together on this webinar, you've got millions of containers, carts, and sub-assemblies rotating around the world. Manufacturing is built on material flow. Many of our customers have large cap manufacturing plants that are transforming literally billions of dollars of material every year. And so when you talk about identification in manufacturing, you're often talking about material. It's really all about the material. Yes, there are cases of tracking tools, there's tracking people, there's some other things going on, but the big money is in material. And material largely flows around in returnable containers. And so one of the key things we'll talk about a lot is solving some of the container problems and getting better solutions for that. But in addition to talking about material, the demands on you as manufacturers is changing dramatically. In the 70s, when a lot of the Kanban principles came across and we started changing manufacturing then into a much more visual system, we still had mass production, very consistent, very uniform products. You'd set up a line for car manufacturer, for instance, that line would run for 5, 6 years with no changes. Now we set up a line, it has 6 different models on it with 40 variations, and you're going to be asked to change it out for a new update in 18 months. It's unprecedented, that amount of change and that amount of complexity, but even worse than that, your customers are now wanting to look inside your plant. They want to order that purple shag carpet, and they want to see their car being built and what stage it's at and when it will arrive at their dealer and where it is on the train. Companies like Amazon have set an expectation, and that expectation will continue to grow, that there's a full transparency through your system, that they can really understand what's going on when they make a buy, and that they can have it exactly how they want it and understand it and predict it. That kind of environment, paper labels can't keep up to. And the old tribal knowledge practices we've had in manufacturing for a long time, even good ones like the Toyota production system and Kanban, really can't stand up to what the future is bringing us. And that's why so many firms are investing in industrial Internet of Things. It's clear that IoT is the solution. We have to find a way to make these materials smart, make the machines and the materials interact and the humans interact together in a way that is more autonomous and much more transparent with a much more data-rich environment. A lot of things factor into that. But I wanted to set that perspective for everyone on the call. So a few quick goals that everyone is talking about as we talk through it. So the first IoT goal is identity and tracking. Clearly, this is one that was well covered already. I think that both Mark and Richard covered this in good detail. There's a lot of good reasons why you want to identify and track things. It helps you eliminate loss. It helps you optimize queues. It helps you do all sorts of interesting things in your production. But it really isn't sufficient to do everything you want to do. But it clearly is a key goal. You want to do identification and tracking. And obviously, RFID ticks this box. The second goal that we talk about a lot in IoT is object-specific sensing and signaling. Now, this really relates to a number of different factors. One can be that the material becomes smart enough to sense its environment. We certainly have seen this for years in things like cold chain applications where you want to know if the temperature rose above a certain degree Celsius. But also, we look at it in terms of location today. I think Richard gave a really good summary of some of the RTLS things that are going on in the marketplace that we're participating in as well, trying to have a material know where it is within the process. But all sorts of interaction is possible too. One of the great things about IoT is having devices become smarter and smarter so they can interact with your workers and with your cobots so that they can talk to each other and be very specific on their object. That object can be very specific about what needs to happen. So a goal of IoT certainly is that objects can sense and signal. They can speak and they can perceive, find ways to interact within the process, much, much different than the paper-based systems we've had in the past. A third goal is the decentralization, and along with decentralization, creating reliability in the process. This is a very different way to look at your manufacturing process, being able to spread the decisions out and let devices interact, effectively have material arrive at a workstation and say, paint me blue, is very different than having a demand trigger that comes from on high and demands that the object be painted blue, as an example. Having that decision-making and control spread to the edge enables all sorts of things in terms of efficiency and also reliability, having the checks down low where the action actually happens. We talk in a lot of our committees about points of interest, and I think Mark actually made a good point in his presentation about your RFID infrastructure serving multiple purposes. One of the purposes of a good RFID infrastructure is to serve as a trigger at a point of interest, so that as material or people or documents or machines like cobots go past certain places, those triggers can cue an action or create a system of events that will happen to realize the objective at the end of the day. So decentralization and reliability is enabled by some of the infrastructure choices we make, and I'll talk about that here a little bit further on, but it's certainly another goal of the Industrial Internet of Things consortiums and the standardization bodies that we participate on. A fourth goal is aggregation, and this is obvious to all of us working in manufacturing. We often have a slogan here at Omni-ID where a lot of what we do is about find the one, count the many, and measure the goal. Being able to see in this mass of material, literally millions and even billions of dollars worth of material spread throughout our organizations, where it is, how much of it we have, where it's sitting in different places and different statuses, being able to manage that flow is a daunting task, and being able to create a system in IoT that can do that for us is a key goal of the many different technologies we're developing now. So there's algorithms being developed to reduce that complexity, a lot of queuing theory. Neural networks is a really fascinating field beyond the scope of the call we have today, but the way that we're working to aggregate and pull this very complex dance of material, machine, and human is really an exciting part of the development of the new technology. And lastly, although it appears I've frozen, which means I might go spinning past having clicked it a couple of times, the fifth goal is autonomy. Clearly, one of the reasons we want to make things smarter is that they can perform even when the system has other goals or is busy doing other things. The autonomy allows a simplification. Whenever you bring a new technology to market, it's really challenging for people to get their heads around. And if it's too complex, it ultimately fails. IoT has to be incredibly simple. It has to be autonomous in that it can do many of the simple setup things and interactions without a lot of complex decision-making on the user's part. This is the same for your smartwatch or your smart fridge that you're working with in IoT. It's the same on the plant floor, where you have workers and operators that aren't going to have a lot of technical background and deep expertise. So the ability to act autonomously without human intervention really extends also to the ease of use of the technology, that it can do many things on its own and base-level functionality. Certainly, the elimination of some of the manual setup steps within the process also happens here. A lot of what we do as we consult on the different plant floors is to eliminate some of the tribal knowledge checks and balances that were there, having humans look at a paper ticket and say, is this material at the right stage? Do I need to put it in this particular oven so it can make the 4 o'clock truck? Those decisions can all be made autonomously and not involve your workers, obviously creating opportunities to use their time to do other things and creating greater reliability in the process. So with those 5 goals in mind, I wanted to talk about how it's done and really do some more fun things like talk about applications we've done. So hopefully it gives you some ideas of how IoT is actually improving the edge and giving you transparency at the edge. So 2 basic parts. First, using RFID, really the simple track and trace we talked about at the beginning of this presentation, being able to track and trace and know where things are. And then we'll talk about e-paper on industrial IoT tags for process control. This is the concept of not just passively tracking, but being able to change what happens by dynamically sending instructions and telling operators to do things differently or telling machines to do things differently in the midst of the process. That's a really exciting part of our practice and what we're doing with many, many customers. So first, let's talk a little bit about some of the RFID applications. So one application which has always been there, storing production data through a cycle. Yes, doing this in software is certainly one way we do it, and we do it often that way. But there are some processes that are PLC controlled or increasingly robotically controlled, whether it's cobots or robots, being able to talk to the process where identifying the exact material in front of you and what needs to happen to it is an increasingly important thing. And many manufacturers are finding storing that information directly on the object is a worthwhile exercise to be more reliable and not trust on database lookups and trying to identify the object. So for that purpose, high memory tags are used. Tags that can store production data, opcodes, parameters that might control the process, the temperature, the pressure that needs to be applied, the type of paint that needs to be used, can all be stored in the tag so that machines and operators can recognize what they need to do when it arrives at their station. So this is an example of a high memory RFID tag. We call it our Adeptate 50. It has 8 kilobits of data on it, much larger than a standard EPC field. And it really serves a purpose in UHF that was previously served in HF. So if you're wondering, I'm using HF RFID tags, but I really want to get more distance, be able to have a more flexible cell where I can be standing off a lot farther from the equipment versus a very close proximity HF read, you might want to look at a UHF high memory RFID tag as a new technology that can enable that for you. Another application that you'll see in this kind of flow is production history of tools and different products. This is really all about embedded RFID. You may not have been aware that you can put RFID directly into your products, even when they're heavy metal products. I show on the top right of the slide some RFID bolts. We've done a lot of RFID bolts and screws where we put a transponder directly into the head of the bolt or the screw. We've even done a hitch pin, as you see on the top right, where you drop in a little ball bearing spring-loaded pin into an assembly and have that pin travel through, and then you can take it out and reuse it again on another cycle. So the idea of dropping tags easily onto your assemblies, even as they're traveling through relatively harsh environments, heavy metal environments, a lot of stress or impact, that's very possible today, whereas 10 years ago, certainly it was not. So being able to keep the production history, track your tools, track some of your equipment, certainly is possible, and we wanted to make sure you're aware of that as you think about tracking applications. Another one that we get asked all the time is about high temperature process exposure, whether it's paint booths or sterilization. This is a huge area that we sell a lot of high temperature RFID tags, whether they're hard tags like this in the ceramic or the polyamide paper style tags or labels. We certainly have a wide range of high temperature tags that are doing 225, 250 C or even higher. You have opportunities to take care of that through your process. So secure data in those high temperatures is now possible, where again, 10 years ago, it was a dream and you really couldn't have anything that would survive reliably thousands of cycles at high temperatures like we can today. Another application that I'm sure you're familiar with if you're in manufacturing is RTI Management. I think Mark talked about it a little bit in his section as well. Losing these containers, keeping track of these containers, knowing what's in the containers, it's a huge piece of what all of us are worried about. There's a lot of value in the container. So the key is to have an RFID tag that is cost-effective, but also fits the type of container you're on. It's very different to slap a label onto a plastic bin versus onto a metal rack that's going into the stamping machine and picking things up and side panels. So there's a wide range from harsh environment tags that can be made out of polycarbonates and very strong or even steel tags, right down to simple labels that enable you to track any kind of RTI that you might have. So if you've ever worried about that, don't worry about that. Certainly there's a tag for every case there and gives you the ability to track those containers in the efficient process flow. Lastly, finished goods are a key topic here too. We certainly do a lot more now in finished goods than we ever have before. You may not be surprised to know that vehicles, for instance, are getting more and more RFID tags embedded directly into them, into the frames, into the seats, into some of the key components such as airbags. We did a count on one of our customers, and 23 RFID tags were actually shipping inside that car and different components and different assemblies. So I think that increasingly we're seeing finished goods having those tags. And much like Mark talked about multi-purpose, you can use those finished good tags for a lot of different things, whether it is for your QA check, your cleaning process, your load process when you're loading the train to go to the dealer, whether it is your final packaging steps to disposition it, or even your reverse logistics if you're receiving back returns or warranty claims. There's a lot of things you manufacture where applying a tag strategically into your finished goods can really make your process more efficient. And I think you should consider that. Again, much like we talked about in the previous slide, tags don't have to be obvious. There's a lot of ways to put them into your product in a way that it won't affect your use, but will give you all those benefits of RF-enabled identification from a distance that will help you and streamline your process. So we do a lot of finished good tracking. But beyond tracking, and I really want to take a few moments here just to talk about a little bit more than just tracking at the edge. Can IoT mean more in manufacturing? And this is probably what I spend more of my time on than anything else as I talk to some of the executives at our various customers. Yes, they understand barcodes, they understand RFID tags, and they're interested in getting that data, and that's all valuable. But the difference is knowing why I missed the 4 o'clock truck yesterday versus impacting my shipment so I can make sure I make the 4 o'clock truck. There's a vast gulf between those two. And enabling transparency into my process where customers can see inside my plant or even change the demand triggers is a whole another different thing as well. So we often use the analogy of GPS, since so many of us are used to that. Imagine if you punched in your route for the day, and anytime you made a turn off of that route, you'd be completely lost because there was no recalculation. That's kind of how we run a lot of our factories today. We have a scheduler who schedules a bunch of material to come in, there's demand triggers, and we plan for the happy path that everything goes well. But when something goes wrong, a machine goes down, a supervisor doesn't show up for work and we have to plan around it, a demand trigger changes, a warranty return happens. All these things are disruptions, and our systems have not been built robust enough that they can handle that roadblock and recalculate. So imagine a world where rather than just collecting data, you can actually use that data and change the outcome that day, make a difference in your cell that shift so that things can collaboratively work together and recalculate and get around those disruptions that inevitably happen. That's the promise of IoT. It's not just a new way to track. It's a way to change the way that the outcome happens within the plant and the cell. Now, one of the ways to do that, not the only way, but one of the ways that we do that is through visual tagging. We want to feature this because it's maybe something new for many of the listeners here on the webinar. Visual tagging is the process of taking RFID, which is kind of a machine-readable format, RF signals that can be interpreted in binary code, and adding in operator visible screen, in this case an e-paper display that goes directly onto the tag or transponder. The e-paper allows you then to put in symbols, text, even barcodes that could be scanned with vision systems so that you can get immediate communication right at the cell. So why is visual tagging important? Well, what the 70s taught us when the Toyota production system came over and we got to be efficient, we implemented systems called Kanban, which literally means billboard or signboard, because we saw that workers respond best to visual cues. When you see it in front of you, you do what you're seeing. And still, despite the advent of many other systems, whether it's audio headphones that you're wearing or other signals, the visual signal is still the very best way to train operators and ensure compliance with the process. So the idea of visual tagging is powerful. The technology has gotten to a place where e-paper can be done so cheaply and can be updated so well that this has become a very important technology in many, many manufacturers and is pervading, it's our highest growth area, pervading many of our processes. So I want to tell you a little bit more about that and why visual tagging is so important. So it starts with visual tags being smart tags. I talked a little earlier about smart material equaling IoT at the edge. Ultimately, your design goal should be that your material should be intelligent. It should be able to know where it is. It should be know the state it is within a recipe or a path. It should be able to tell workers and machines around it what to do with it next in a very autonomous, distributed manner. In other words, material should be able to say, put me on the 4 o'clock truck, paint me blue, take me to the next QA station, or I'm on hold because of this. That idea of smart material really is the concept of IoT, that the material can start to interact and enables a world of possibilities and efficiencies that we haven't had before. So visual tags are RFID tags. They do give you all the tracking functions that you normally get out of RFID, but they add in dynamic instructions, operator interaction, both through the operator seeing things, but also things like push buttons or key fobs that can give digital signatures or interact with it through RF. It enables automation with machinery so that machineries can query the tag, whether they're robots or AGVs, and it gives real-time visibility to your process. That visibility is really two ways. It's both visibility for your workers to see what they're supposed to do, but it's visibility to your supervisory system that can now see the plant in a very granular manner, seeing all the material that's there. And it does all of this while eliminating the high cost of paper. I talk to so many of our customers about how much it costs to have travelers, paper worksheets, stickers, labels, cards, maintaining all those printers, bringing paper to the printers, bringing toner to the printers. There's an immediate cost savings just by eliminating all that paper. But the true benefit is all of the data and the process efficiencies you get. But it's nice to have a hard cost like paper to take off of the books as well, and it certainly does do that. So a few how it works. Work instructions is a good example. This is an application that we do a lot of with visual tags. You may have a process in your factory where you send a paper sheet, or what we call a traveler, with your goods. We see in the picture here a skid full of valves, and each of those valves has a build sheet that tells the operator on the line what to do with it next. Seat an O-ring, couple it onto this, test it for pressure. Whatever the instruction is, it comes with that traveler. Imagine this now having an intelligent transponder on it, where as it goes station to station, the worker can see it dynamically and can see those instructions. Yes, it eliminates the paper, but it also means now you see where the material is at any stage in the process. It allows you to be more explicit about instructions. So say you had a problem yesterday with seating the O-ring in that valve, and with it not being seated correctly, you're failing the pressure test at workstation 23. So how about at the O-ring station, now you put a picture up on the e-display, and it says to that worker, make sure you seat the O-ring this way, and it shows them a picture, and it also says press the button to confirm that you did it. Imagine how that impacts your quality the next day, and how you're able to teach perhaps a line that was doing something wrong a better way. That's an example of electronic work instructions being much more clear and improving your process. But in addition to that, you can capture the as-built instruction. Because it's an intelligent tag going through, not a piece of paper, you know exactly when it went through the workstation, who worked on it, and can capture all of that data in real time if your customers are looking for that kind of transparency. And increasingly, they are. Another good example of work instructions, this is a company we worked with in Detroit Diesel, a Daimler facility. They build large engines for trucks. They had a very large build book, many, many pages, that would detail exactly how the engine needed to be built. By replacing that book with an electronic visual tag, we tracked the engine's progress through the different build stations, which was many hundreds of yards long, and allowed us to get rid of the cost of the paper, but also dynamically control what happens with that engine. In many cases, adjustments are made, shims are added, and this electronic work instructions is a much more efficient way than the static paper to do all the markups. Another application you do with visual tags is picking. I'm sure many of you have picking operations in your plants. It's a fundamental thing that happens in almost every manufacturing facility to gather up the materials for the production run and feed the main line. There are many systems that historically have been there for picking. Everything from the traditional sheet of paper where you get a pick list printed at a printer and the picker just walks in and uses the list just like a shopping list and checks off gathering up the material. Certainly pick-to-light systems have been a big deal for a long time, and now pick-to-voice or pick-to-sound is out there doing a lot of things. But consider the advantages of pick-to-image or visual picking. If you could put these smart tags on every shelf edge without any wiring, without any pre-configuration, and these tags can tell you where they're located so you don't have to worry about coding it up or programming where your supermarket's at. And now you can actually light these tags up. You see in the little diagram on the bottom right how the tag has gone to a dark image or a white on black versus a black on white. That's very visible down the shelf, just as visible as a light is on a pick-to-light, being able to say that, yes, this is where I've got to go. And now not only do you have the ability to see that that's where I'm supposed to pick, you can give instructions. Maybe you're picking a quantity of 3 instead of a quantity of 1. Or maybe you've got a pick cart that has slots or that's sequenced. And when he picks those 3 parts, he has to put them in a very specific order on the pick cart. Or he has to sequence them on a stack on top of his shopping cart. All of those things are possible with a visual tag that aren't possible in other systems, or at least aren't easy to do in other systems. So what you get with this, you get quick configuration. You get a completely wireless setup, so you don't have to worry about that. Remember earlier we talked about the changes where there's more complexity and more reconfiguration? It used to be you'd set up a pick zone and it would stay that way for a few years. We have customers that are changing this thing on a weekly basis, where they get different order configurations and they want to reconfigure their supermarket. The fact that it's wireless allows you to reconfigure effortlessly. They used to take, one of our customers used to take almost 2 weeks to rewire a pick-to-light system that they were using. They put this system in and they could reconfigure in 2 hours with no help and no technical personnel. You get standard templates that make it easy to display the data and actually take your work instructions and put them right down on the shelf edge the way you're looking at it. Another great benefit of visual picking is when you've got unskilled labor that comes in at different times for surge capacity. We have some customers that bring in temp labor a lot, and training used to consume far too much of their contract or their time. It might take them several shifts to get acquainted with what exactly they're supposed to do. They saw dramatic reductions, 80% reductions in some cases, of training time while employees could look at the visual pick signal and look at instructions that they had to confirm and press a button and understand. It greatly eased the ability to bring in temp labor. Then, of course, you get the real-time reporting aspect that you'll really see in real time where everything is and be able to track. So picking is a great candidate for using this new IoT technology of visual tagging. It really does save a lot of money and streamline the process. One that's very related to that is replenishment, and here's where it works a little bit hand-to-hand. So again, replenishment's a key feature, bringing goods from your warehouse to your line side or into your picking supermarket. Many customers use a kind of go-and-see methodology where you put up flags, or workers just go and look to see if the bins are getting empty, and they go bring the replenishment. Some use call buttons where there might be a button there to press, but the call button really is just that, like a doorbell, to say that I see that I'm empty. Visual tags allow you to give better instructions and dynamically reconfigure those replenishment cells. You can change part numbers, move the part numbers around just like you do in a supermarket. The call can still be a push button, or it can be a sensor. The tags have sensors built into them and have sensor attachments that can be added to them to allow them to sense when there's not a bin in the area or not a second or a third bin if you're using a 2 or 3 bin system. And so that call goes automatically. Not only does the call go automatically to the replenishment operator who's driving the tug or driving the high-low, but you get a a message for the operator to say the call's been sent, as you see in the little thumbnail that I have here on the slide. Visual tagging provides the transparency in the process that reassures your operator that everything's going as it should be and keeps everything running properly. The elimination of errors and downtime is tremendous using a visual system, just like we found out in the 70s when we were using paper Kanban cards. Again, another good case study here with Daimler, who used our replenishment system, calling for parts. They used to use little orange flags like you see in the top picture, and they moved over to a fully electronic visual tag, and the savings have been tremendous. Again, I won't deal on it. There's a great application story on our website if you want to read in more detail about this particular installation, as we're getting a little short on time. So, just in conclusion to talk about this second phase here, well, RFID does a great job of track and trace, and certainly that can be your only goal of your project. You may decide all you need is tracking and tracing and ability to kind of identify materials as they flow through your process. I hope you know from this presentation that RFID is more capable than it's ever been. It's more reliable than it's ever been. We're able to put it into tough environments like heat or directly embedded into metal. So if you're looking for a track and trace project, you really should have a look at RFID. It's come a long way. It's cheaper and more reliable than it ever has been. If you're looking to move into IoT and really take advantage of some of the autonomous, self-regulating, communicating with your workers kind of technologies, you should look at perhaps more intelligent transponders, intelligent tags that can also be tracked and traced, but can also now interact with your workers and your machines in a very interesting way. There's great efficiencies in using these wireless visual tagging systems through many of your processes, and rather than just track and trace, you can dynamically control your process, change instructions, change the goods flow through your organization in real time. And that's a huge jump and really is the Industry 4.0 or next generation of industrial manufacturing. With that, I think I'm right on time. I'll conclude. I'm happy to take some questions if anyone has questions for me.
Okay, Ed, thanks very much. Folks, if you have a question, we have a little bit of time for questions. How would you easily encode the tags if they aren't printer encoded without manually and individually encoding?
Great question. So you have a couple of options, and I assume we're talking about RFID tags, a straight RFID tag. But I guess it really doesn't matter which of the technologies we've talked about. If you're not running them through a printer, which automatically matches up the print image with the EPC number that you're encoding, you need to have a little software script that is going to be hitting that, putting into that ID space the ID that you need. So if you don't have that, you need a good integrator or a provider that can go ahead and create that little script from your system to be able to identify those tags and encode them. It's really easy to do. It's not difficult. And of course, you can order your tags pre-configured for you if you have a list of IDs that you want. But if you're not printing them and doing them automatically, you'll have to create an automated system from your back-end system.
Okay. Ed, when is it necessary to use high memory tags instead of cloud-based solutions?
Another really good question. So I have to say that it almost never is necessary if you are willing to open up your manufacturing floor to the cloud. The challenge is that there still is a lot of give and take between controls engineers and IT departments. And when you're running a robotic cell or a PLC-based control area, there's a lot of resistance to having IT or cloud-based software giving key production data into the process. And so what we're seeing is a good preponderance of the market still wants that robot or that PLC to be able to read everything it needs to know directly off of the material coming through it rather than making a call to a cloud and trying to find out what data needs to be there. So technically there isn't an issue. You can do it either way, but there's a reliability and comfort in not having those software structures impact your day-to-day operations that people are still relying on.
Okay. This is a little bit of a baseball analogy, but what inning would you say we are in when it comes to the adoption of RFID in the industrial sector in the U.S., Europe, and the rest of the world?
Oh, Boy, that's a very broad question, and using baseball on it. I think Europe is the most advanced. Our European manufacturers in particular have adopted RFID through many of their processes. It's actually rare for me to find a European manufacturer that doesn't have some RFID somewhere, and many of them have major programs right now expanding their adoption. So I'd say we're kind of in the mid-innings in Europe. We're clearly in the early innings here in the U.S. I would see still 80–90% of our processes in the U.S. are paper-based. There's very limited adoption of RFID on the overall scale here. But with the nearshoring and the reshoring that's happening in U.S. manufacturing and the push to reduce costs and to get better systems in place, there are tons of programs going on with large manufacturers now trying to use RFID as one of the technologies to solve their efficiency problem. They often have it under an initiative called digital transformation, but whether it's Industry 4.0 or digital transformation RFID, I think we're in the early innings, maybe the first or second inning in the U.S. In Asia, we have several countries that are state-sponsoring RFID, China being notable, where RFID is one of the 5 pillars that the country has officially positioned themselves to say we will be leaders in this technology. So there's many state-sponsored programs, a lot of learning at the state universities, a lot of adoption, really for adoption's sake going on. So still early innings there, but a very different impetus happening versus the kind of the reshoring happening in the U.S. for RFID adoption.
Okay, I think this is the last question we have time for. You showed a visual pick-to-light system with no wires. How long does it take to set up a picking market when you have no wiring?
Yeah, we have a great international customer right now that's been doing this. We're on our 8th or 9th plant in their rollout process, and we've got a ton more coming. They're down to where they're literally doing it in about an hour and a half, where they used to take them about 2 weeks to rewire and reprogram an entire supermarket. So these are pretty large supermarkets. Even for a small manufacturer, you might be under an hour to set the whole thing up. You literally just slap things together, stick a tag on the shelf base, associate the tag automatically, and you're ready to pick.
Okay. Ed, thank you for an excellent presentation. Appreciate you taking the time to present today, and thank you for your support for this event.
No problem.
Okay, folks, just a little over time, but I want to remind you that you will be able to review today's presentations and any past virtual events or webinars by going to rfidjournal.com/virtual-event. /videos. You need to be a registered user. We will send you an email after this event with the link. If you're not already a registered user, then just create a free account. You'll be able to view the presentations. I want to thank our platinum sponsor, Omni-ID, and also our gold sponsor, HID Global. Without their support, these events are not possible. Also want to remind you that RFID Journal will be hosting our flagship event, RFID Journal Live, in Orlando, Florida, from April 10th through the 12th. This is our biggest event with some 200 exhibitors from 25 countries around the world. So, we also have about 100 educational sessions, so it's the place to be if you want to learn about RFID. And if you use the code PHSX and you're not already registered, you can get a 15% discount. Lastly, I want to thank our presenters for doing a great job today. I want to thank you, ladies and gentlemen, for joining us. I hope you'll join us at RFID Journal Live and for future online events. This now concludes today's presentation. Have a wonderful day.
Thank you. Bye.